Now I can go back and make a better presentation.
Well,
I'd rather err on this, not go use that line here. I'd rather
then
go back and pick it up. Side.
or like.
All right. So, hello, everybody. Let's get started. We were doing a little bit of calculations for the agents and buffers and reminders of some general chem principles. So pull back your piece of paper that you started on Monday. Make sure your name is on it. And let's start with this exercise. Remember, this is for a +2. You hand it in at the end of the lecture. Make sure to take a picture of it so you have the calculations for you when you are studying. All right. So calculate number of moles of calcium in 25 grams of calcium chloride with 2 moles of water. Okay, so things you want to know is number of moles equals mass in grams over molecular weight, also in grams. Another thing you want to know is the molecular weight of calcium. What's the molecular weight of calcium? Anybody remembers? 40. And then molecular weight of chloride. Anybody remembers? 35.5. Molecular weight of oxygen, 16. Molecular weight of hydrogen. Okay, if there is any question in an exam or quiz that requires to do similar calculation, I'll give you the molecular weights of the elements. I won't have to remember those. Okay. The other thing you want to notice is in this, if we say 1 mole of this molecule, in 1 mole of this molecule, how much moles of calcium are there? 1. Okay. So you want to keep that in mind as you think about this question. Okay, give it a go. So we're doing exercise that we started last Monday. So that sheet for +2, make sure you have it and you continue on it. And if you got an answer, share. You have an answer?
Yeah, 0.17.
0.17 moles. Yes, correct. So how did we get to that? So basically, I gave you the mass. So we're looking for number of moles, and molarity equals numbers of moles over volume. But I'm asking you for number of moles only. I'm not asking for molarity. I'm asking for the number of moles. We have the mass, 25 grams. And the molecular weight, you just get 40 and then 71 and 2 oxygens, that's 32 plus 4, So what do we have? We have 147. Is that correct? All right. 147 grams. That's 0.17 moles. So this is the moles for the entire molecule. But since I have one calcium, so if the number of moles of this molecule will be equal to the number of moles of the one calcium here. Yes. So it's actually grams per mole for the units. So you want to always have your units so that this cancels and the number of moles go up. Always remember to have your units. Okay. Let's think about that. This one you will be actually preparing NaOH in one of the lab, NaOH reagent. And depending on the stock solution that we give you, you would want to determine how many milliliters you want to take from the stock solution. So solve it from a stock solution of 3 molar, and then from a stock solution of 45 molar. So let's start with the 3 molar, solve that first, and then we'll go to the next one. So you want to prepare 1 liter of 0.2 molar NaOH. So you have to remember the concentration by volume equal concentration by volume. So this is your equilibrium equation, and at the same time equation used for dilutions. So you want to put the given and then determine how you prepare a liter from the stock solution. All right, when you have an answer for A, then does anybody have an answer? Would go with Kevin. Great.
So I have 66.6 milliliters of 3M NaOH, 1 liter of water, or in a volumetric class made up of water.
Yes, perfect. So we'll get that. So you have your stock solution, which is 3 molar. We want to know how much volume in milliliter I need from that stock solution to prepare a 0.2 molar solution that is 1 liter or 1,000 milliliters. So how much volume or how many milliliters I need from the stock to prepare a 0.2 molar that has 1,000 liter in volume. Okay, so I'm solving for my volume in milliliters, so 0.2 molar times 1,000 milliliters divided by 3 molar. Molarity unit cancels, so my last unit will be in milliliter. And that's how you know that you are doing the correct math, when your units cancel and you get the correct final unit. And then it is 66.66, so it's 0.7 rounding milliliter, so I get the volumetric flask, I put some water in it. I add my 66.7 milliliter of 3 molar NaOH. And then I make up to volume, that is 1 liter. I make up to volume with water. Or DDW or double distilled water. Okay. Good. Now, another stock solution I have is 45% weight by volume. Anyway, so now my stock solution, the concentration I gave you for my stock solution is in percentage. But I have the concentration of the final solution is in molarity. So I want to unify the units. So here, the first thing that I want you to practice is how do I unify the units? How do I convert a percentage to a molarity? Okay. Are we good with this? Can I erase here? Okay, so what does 45% mean when I say weight by volume? Can you convert that percentage to what it means? Yeah.
Could you just do like 45 grams per 100 milliliters?
Correct. So 45 grams per 100 ml. That's what 45% means. So 45% in weight by volume. When I say weight by volume, it's basically 45 grams in 100 ml. All right, convert this to molarity. What would the molarity be of this solution? Think about it and let me know when you have an answer. Anybody with an answer? Yes, Medora?
It'd be about 17.8 molar.
Yes, 17.8 milliliters. Perfect. So let's do the math for this one. Okay. Molarity, so I'm after molarity, okay? So I want to get the molarity of this solution. That's how I start first. I go molarity equal number of moles per volume, and usually it is moles, the units, moles per liter, per 1 liter. Okay, I have this in 100 ml. Okay, normality, number of moles equals, I want this number here. Number of moles equal mass in grams over molecular weight in grams per mole. I need the molecular weight of NaOH, which I forgot to give you. All right, sodium is what, Medora? What's the molecular weight of sodium?
Well, I just know like 39.
Yeah, the whole thing's 39.9, but okay, so 23. Oxygen is 16. Hydrogen is 1, so it's basically 40 grams per mole is the molecular weight. All right. So I need the mass and I have the molecular weight. Okay, if I want the mass, this tells me 45 grams in 100 ml. But I want in a liter, in 1,000 ml. So 45 grams in 100 ml, how much in 1,000? So I multiply, so I would say 45 grams in 100 times 1,000, because I want 1,000 milliliters. So it would be 450 grams. So this is 400. 450 grams. Okay, that's in a liter. So I have 450 grams in a liter, so that's what I would put here, 450 grams over the molecular weight, which is 40 grams per mole. So now this is, what was that? 17.8 moles. No, that's 17.8 milliliter. What was the molarity? 11.45, yeah. Okay. 11.25 moles. Okay, so now since I converted to per liter, so the molarity is 11.25 moles per liter. So this is the stock solution. Now I have, which is molarity. I have unified the units. So now I can do the C by V equals C by V. I have the molarity 11.25. I'm searching for the volume in milliliter. I want to prepare 0.2 molar, and I want to prepare 1,000 milliliters. So then the volume is 0.2 molar times 1,000 milliliters by 11. This is molarity. Just to be clear, we always want to keep the units. Okay, 11.25 molar. So units cancel, and then this is the 17.8 milliliter. And then again, you get your volumetric flask. You put a little bit of water in here. You add your 17.8 milliliters of your stock solution, and then you make up the volume with PDW or double distilled water. Okay. Good. These are the answers, same what I have here. Okay, you're good. We'll continue. All right, more exercise. We have to prepare, in this case, not a liter, 500 milliliter of 0.1 molar H2SO4, sulfuric acid. And usually we buy sulfuric acid bottles that are concentrated, and on the bottle, they tell us that the concentration is 98%. Volume by volume, not weight by volume. Volume by volume. And they give you the density of H2SO4 in 1.84 grams per milliliter. So it's volume by volume, and they give you the density. So you can basically calculate the mass. If you have the volume and you have the density, you can get the mass. So I want to convert this concentration to molarity, because again, same as the last example, I want to unify the units. I want to get one molar. So I want to know the molarity of my original stock solution. And here I'm giving you the molecular weight of H2SO4 right away, 98 grams per mole. Professor, you can ask. Do you have any questions? You got it? Okay. Go for it. It's a little bit similar to what we covered, but there's a little bit of a twist. You're a graduate student in a lab, or if you're working in industry in a lab, you need to figure out the normality or molarity of a given solution when you buy the stock acid, and they only give you this on the label. They give you the purity. Anybody got the molarity of H2SO4? Ash?
Sorry,
The H2SO4, did you get the molarity of that?
I mean, 0.2 molar.
Oh, no, the original, the molarity of the original solution, the
Oh,
stock.
I didn't do that in my process.
Oh, you didn't do that in your process. Okay, what was did you get the final volume then?
Yeah.
What was it?
I got 10.87 milliliters.
No. So you probably need to go through that process of getting the molarity of the H2SO4. Okay.
Guys, I got the molarity as 0.18 only.
Not even. So the molarity of the stock solution,
Yeah,
did you, the percentage, remember it's per 100 ml, did you
Yeah.
convert it to a per liter? No. Okay, maybe there is a calculation there.
So 18.4.
18.4, yes. All right, I will talk you, Kevin, through this. I will talk you through this. Okay, so 98% volume by volume. This means 98 milliliter in 100 milliliters, right? So they gave me the density. So I want to convert 98 milliliters to grams, to mass. And then remember, density equals mass over volume. So if I multiply my volume by the density, I get the mass. So my density is 1.84 grams per mil. And then I'm looking for my mass in grams, and the volume is 98 milliliters. What is the X? Anybody did the math? So 98 times 1.84, this is milliliters, this is grams per milliliter. So the units will cancel. What was that?
180.32.
180.32.
Over 98. Oh, you were asking for the.
Just 1.84 times 98. Is that 180?
Yeah. Sorry. Yeah. Yes.
180.32?
Yep.
Is that right? Okay. So then I got the grams in 100 ml. All right, so I have 180.32 grams in 100 ml. I need to know how much I have in a liter. So basically, I want again in a liter because molarity is in liter. Then I would say, okay, I have 100 of 1,800, no. 3.2 grams. So I got my mass. Then I can apply this equation. Then I would say N equal 1803.2 grams over 98 grams per mole. What do I get here? Is that the 18.4? Yeah. 18.4 moles. And since this is in a liter, because I converted to liter, I can say my molarity equals 18.4 moles per liter. Because molarity equal number of moles per liter, moles per 1 liter, and that is the moles per liter. I converted to 1 liter here. Okay, so now I got my stock solution. Sarah, did you get that?
yeah, I got 1-0.
You dropped the
Yeah.
0. I knew that there was a 0 somewhere. Okay. And then I apply here. So my concentration is 18.4 molar. This is the volume in milliliter I'm looking for. I want to get 0.1 molar. And my volume is 500 milliliters. So 0.1 molar times 500 milliliters over 18.4 molar Molarity cancels. So what's the volume? 2.7. Okay, 2.72 milliliters. So in this case, I want the 500 milliliter volumetric flask, which we can get. Again, I put my water. I add my 2.72 milliliter of concentrated H2SO4. I make up to volume, which is 500 milliliter in a 500 milliliter flask. So when you solve, you want to make sure that you put all the steps, including the last step of how you would prepare. Okay, any question? Yes, ma'am.
Is it okay if I have the steps kind of change around a little bit?
I don't care as long as you have the right answer. Everybody thinks a little bit in their own way. As long as your steps make sense and you get the right answer. Yeah, and I also do the math old school, different than how you were taught. So sometimes you don't get my math, but you have your own way of doing your math. That's exactly what I have here. If you wrote all of this down, you don't worry about this. Any questions before moving on to a dilution problem? Okay. Many times you want to prepare standards, and you will be doing that in the lab. And to prepare standards and to produce a standard curve, you would want to do different concentrations. So you would work from a stock solution and you take different volumes from the stock solution and make up to a specific volume, then you end up with like 4 or 5 different concentrations that you would use to plot your standard curve. So this is an exercise that will give an example of how we prepare diluted standards to run a calibration curve. So here you are measuring anthocyanins in raspberry juice. And in order to calculate the concentration of anthocyanin in the juice, you have to run an anthocyanin standard curve. So basically you buy an anthocyanin standard and you prepare a stock solution. And from there, you want to prepare 2 milliliter of your standards that have each of those standards have a concentration of 0, that means nothing. It will be 2 milliliter of water or buffer, depending on your experiment. And then you want to have 0.1 milligrams per milliliter standard. You want to have 0.2, 0.3, and 0.5 milligrams per milliliter standard. So you want to design the dilution scheme from your 16% stock solution. Give it a thought. What would you do and how much would you take from your stock solution to prepare those 5 standards? Okay, so give it a thought on your own and we will go over it together. a hint, you want to unify your units. Your starting solution has 16 grams per 100 ml. You want to calculate how many milligrams per 1 milliliter. Because that's the concentration you're after. So how do you unify the units? You have 16 grams in 100 ml. No, in 100 ml, not 1,000 ml, so. In 100 ml. You want to get it in 200, 1,000 to get 2 milligrams. In 1 ml. No, milligrams. So you have 1,000 milligrams in 1 gram. And you want it to be in 1 ml. And you have 16 grams in 100 ml. So your concentration is
116 milligrams per.
yes. 160. 160, right? Set. Okay. Milligrams per 1 ml. Correct? Did you all get that dilution, that conversion? Okay, so I'm converting 16 grams in 100 ml to a unit of milligrams in a milliliter. So you have 1,000 milligrams in 1 gram. And then you have 16 grams in 100 ml. You want it in 1 ml. Then you get 160 milligrams per ml. You might put things differently here, but that's your final answer. Okay. So I unify. So to make a 0.1 milligrams per ml, how much do I need of the stock solution? So again, you apply. This is always your equation for dilution. So I have 160 milligrams per ml. And I'm going to look for the volume to prepare 0.1 milligram per ml. And I want 2 milliliters. So what's my volume here? So 0.1 milligrams per ml times 2 ml over 160 milligrams per ml. So this unit and this unit cancels. What do I get?
1.25 times to the -3.
So tell me in decimal,
0.00125.
milliliter. How many microliters is that?
1.2.
Okay, can I do this? Can I physically do this in the lab? Pipette 1.25 microliters. No, there is no tool even, at least not in our lab, to do 1.25 microliters. We need a miracle more than good luck. No, we cannot. We cannot do this. You think about the pipettes you have in the lab, what volume would work good for you? I would say if it was 125 microliters, yes, I can do that. I can get the 200 microliter mechanical pipette and dial it to 125 microliters. Okay, this is 100 times more than this volume. So this tells me I need to dilute my original solution 100 times. Dilute 100 times to be able, not 10, 100 times, to be able to pipette, 125 microliters. So I need to go back to my stock solution. That's what we call step dilution. Because once we do the first calculation, we say this is not physically possible. Even if I dilute 10 times, 12.5 microliters, you can do it, but it's prone to error. We learned in the lab this week that the larger the volume or the larger the measurement, the less associated error. So I'd rather work with larger volumes. And if I want to get this much out of my stock solution, then I need to dilute my stock solution 100 times. So I want to dilute it in the sense that I get 1.6 milligrams per 1 ml. That's 100 times dilution. So if I want to get to 1.6 milligrams per 1 ml, and let's say I want to prepare 10 ml stock solution, you have to come up with how many milliliters of stock solution do I need to prepare based on how many applications I need to run. So you kind of come up with what volume of stock solution you like. And you go, okay, I'm going to prepare 10 milliliter of stock solution that has this concentration. So I'm going to go again and apply this equation up here, called CV, and I say, okay, I want 10 milliliter of my diluted stock solution, and I want it to be 1.6 milligrams per mil. And then my original is 160 milligrams per mil. What would be my volume? Then the volume in this case would be to kind of do the dilution. So I would say 1.6 milligrams times 10 ml. That's milligrams per mil is the concentration, divided by 160 milligrams per mil. So that's 16 over 160, that's 0.1.
Yeah.
So basically, I would say from my original solution, I will take 0.1 ml, which is equal to 100 microliters. I would take 100 microliters, and I would put it in a 10 milliliter volumetric flask, in this case, 10 milliliter. Put water, add my 0.1 milliliters, make up the volume, 10 ml. That means I would put 9.9 milliliter of water. So 0.1 milliliter of my stock solution, 9.9 milliliter of water, get it up to 10. I got my dilution. Now I have my 1.6 milligrams per milliliter. Then I do again, concentration by volume, I have my 1.6 milligrams per milliliter. How much I need of that stock solution in volume. And I want 0.1 milligrams per ml in 2 ml. So now I get my second level dilution. So 0.1 milligrams per milliliter times 2 ml over 1.6 milligrams per milliliter. So my units cancel. So what's the volume here? I think it will be the 0.25. Right? Microliters or 0.125 milliliters, and that's 125 microliters. Correct? Are you all following? Anything I need to review. So you start off and then you determine if it's feasible or not, if it's physically doable based on the tools you have in the lab. If you say, I cannot do 1.525 microliters, I have 200 microliters pipettes or 100 microliter pipettes, I can confidently do 125 microliter. That means I need 100 times dilution, and you work backward that. All right, ran out of time. Next, we will finish up buffers on Friday and start chromatography.
So
Yes,
that 125 microliters, that is then what you would put in a 2 ml.
yes,
And you fill it to water.
from the diluted stock solution.
Yeah.
Yeah. Yeah, so here, let me finish it. Thank you, Kevin, to make it clear. So 2 milliliters, 2,000 microliters. So 2,000 minus 125, what is it? 1,875 microliter of water. Yeah? To get the one. That finishes it off, and it doesn't do it.
Yeah, but you could write it from that. Because yeah, I gotta.